Hi there, and welcome to the first film you might be watching in Year 11. It's about matter and all the different kinds of substance that you're going to study in chemistry. And hopefully by the end of this film you'll know what we mean by an element and a compound, and you'll know the difference between the two main kinds of mixture. Okay, well, let's start off by looking at what elements are. Elements are things that are made of only one type of atom. Okay, now that doesn't mean that it has to be only one atom present. Okay, because if I just had one atom in my hand, I wouldn't be able to see it, but it would just be one atom. Okay, I could have a million atoms. As long as they were the same kind of atom, that substance I had would be an element. So if we look at lithium, for example, you could look lithium up in the periodic table. You could find its symbol. Okay, you'll find all the elements in the periodic table. They're all the elements that we've discovered. Okay, lithium has the symbol Li, and if I had some lithium, it would only have lithium atoms in it. That's what it means to be an element. Okay, if I had some carbon, symbol C, that would also only have carbon atoms in it if I had some carbon, so it's an element. Okay, nitrogen here appears to have a slightly different kind of formula, because a molecule of nitrogen, so that's the naturally occurring form of nitrogen, actually has two nitrogen atoms in it. But because all the atoms in nitrogen are the same, they're all nitrogen atoms, nitrogen is an element. Okay, even though it's made up of two nitrogen atoms for each molecule, unlike lithium and carbon. Okay, just included steel here as another example, but this is actually something that isn't an element. If you look at the periodic table and try and find steel, you won't see it there. A lot of people think it's an element. It's actually mainly iron, which is an element, but it's mixed with other things, and we'll have a look at mixtures in just a moment. Okay, compounds. What's the difference between compounds and elements? Compounds are things that are made of two or more elements. But they haven't just been mixed together, they've actually combined with one another, and they've done so in definite proportions. Now let's see what that means, and we'll illustrate it by looking at the formulas of a couple of compounds. Okay, sodium chloride has the formula NaCl. That means there's one sodium atom to every chlorine atom. Chloride ion, in fact, but we haven't covered that yet. Okay, so because there's always 1-to-1 ratio, they're always combined in those proportions, and the compound sodium chloride, or common salt, always has that formula in those proportions, so it's a compound. Water, as we probably all know, has the formula H2O, so the fact that it is in definite proportions means that there are two hydrogens for every oxygen atom in any water that you choose to find. Okay, if I just mix hydrogen and oxygen together, I can mix them in any proportions that I like, but when they combine together and make this compound water, so two or more elements combined, they'll always combine in those proportions. Ozone, it's just another bold example, maybe an odd one out. O3, it's not the same as O2, which is oxygen as we normally know it, but that doesn't mean this is a compound, because there's still only one kind of atom here. Okay, moving on now to mixtures. Mixtures are a little bit like compounds in that they have to contain two or more substances, but they haven't combined chemically. Okay, and I can mix things in any proportions that I like. So here is sodium chloride solution. That's what this symbol means. It means the sodium chloride is dissolved in water, or salty water. Okay, now I can make salty water very salty, or I can make it not very salty. It will always be sodium chloride dissolved in water, but I can mix it in whatever proportions I like. Okay, marble and calcium carbonate, they're two substances that you may have used in chemical experiments up until now. Marble is made up mainly of calcium carbonate, but it's not only calcium carbonate, and depending on where I get my marble from, it will have different amounts of calcium carbonate in it. So although it's mainly calcium carbonate, the proportions of calcium carbonate to sand or other things can vary, so marble is a mixture. Calcium carbonate, however, has a formula which is CaCO3, and no matter where I encounter calcium carbonate, it will always have one calcium to one carbon to three oxygens. So calcium carbonate is not a mixture, it's a compound. Okay, whereas marble, which contains calcium carbonate and some other things, is a mixture. Okay, all that's left to talk about is the two different kinds of mixture, and they are homogeneous and heterogeneous. Homogeneous mixtures are ones in which the particles of the mixture are evenly distributed. So the things have to be able to mix well with one another. So mixtures of gases tend to form homogeneous mixtures, and so do mixtures of liquids, and so do solids that dissolve in liquids. Okay, so in air we've got oxygen, nitrogen, we've got carbon dioxide and a few other gases. Here's an element, and here's a compound, but when you put them together they don't combine together, they just mix, so they form a mixture. And I could have lots of oxygen. If I had pure oxygen to breathe, I'd have lots of oxygen in the air. There's only about 20% of it. But I can mix these gases in any proportions that I like. But in air, in this room, for example, it doesn't matter if I sit here or sit over there, there's always going to be about 20% oxygen. So no matter where I am in my mixture, I'll have about 20% oxygen, 80% nitrogen, and some very small trace amounts of the other gases. In seawater, it doesn't really matter if I'm swimming in the sea at Cottesloe or at Rottnest, it's going to taste approximately the same. If I decide to drink it, it's going to taste just as salty. Okay, so a homogeneous mixture with a solid dissolved in a liquid means that it doesn't matter where I am in that liquid, there's going to be roughly equal amounts of water and, for example, the salt that's dissolved in it. Orange juice, well, whether that's homogeneous or not would depend on what kind of orange juice you've got. If you've got smooth orange juice, then no matter where you are in your glass of orange juice, it looks the same. It's got the same amount of sugar and water and other things from the oranges dissolved in that water. But if you've got bits in it, then there's an uneven distribution of particles, right? There'll be bitty parts of the orange juice and there'll be not bitty parts. So depending on what kind of orange juice I've got, it might be homogeneous if it's smooth, but if it's not smooth, if it's got bits in it, then it's not an evenly distributed mixture. Okay, and that kind of mixture would be called a heterogeneous mixture, where there's an uneven distribution. Now, things that don't mix well form heterogeneous mixtures. So solids tend to form heterogeneous mixtures because you can't mix them together very well. If I take the raisins and the sponge in a cake, they're not going to combine together. There'll be parts of the cake that have raisins in and parts that don't, and there might be icing on the cake. These things are all together forming a mixture, but they're not evenly distributed. Same thing with concrete. There'll be stony parts of concrete, there'll be sandy parts of concrete. Okay, sandy seawater is another example of a heterogeneous mixture. If we had just seawater with no sand there, then the salt would be evenly distributed amongst the water particles. But as soon as you have sandy seawater, because that sand can't dissolve in the seawater, depending on where you are in this mixture, it will appear either sandy or not sandy. So it would be called a heterogeneous mixture. Now, there's quite a few key points in this film, so it's probably worth maybe watching it again, checking that you've got all the key points. And once you've finished, a good film to watch next is the one about subatomic particles.